Good morning, welcome back to Advent of Code. This is day 20 trench map. With the scanners fully deployed, you turn their attention to mapping the floor of the ocean trench. When you get back the image from the scanners, it seems to just be random noise. Perhaps you can combine an image enhancement algorithm and the input image, your puzzle input, to clean it up a little. For example, the first section is the image enhancement algorithm. It is normally given on a single line, but it has been wrapped to multiple lines in this example for legibility. The second section is the input image, a two-dimensional grid of light pixels, hash, and dark pixels, dot. The image enhancement algorithm describes how to enhance an image by simultaneously converting all pixels in the input image into an output image. Each pixel of the output image is determined by looking at a 3x3 square of pixels centered on the corresponding input image pixel. So, to determine the value of the pixel at 510 in the output image, 9 pixels from the input image need to be considered. These 9 input pixels are combined into a single binary number that is used as an index in the image enhancement algorithm string. For example, to determine the output pixel that corresponds to the very middle pixel of the input image, the 9 pixels marked by ... would need to be considered. Oh, I see. 9 pixels marked by square brackets would need to be considered. Starting from the top left and reading across each row, these pixels are ... then hash ... then hash . Combining these forms ... hash ... hash . Full stop. By turning dark pixels dot into 0 and light pixels hash into 1, the binary number 000 blah 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 can be formed, which is 34 in decimal. The image enhancement string is exactly 512 characters long, enough to match every possible 9-bit binary number. The first few characters of the string, numbered starting from 0, are as follows. In the middle of this first group of characters, the character at index 34 can be found. It's a hash. So the output pixel in the center of the output image should be hash, a light pixel. This process can then be repeated to calculate every pixel of the output image. Through advances in imaging technology, the images being operated on here are infinite in size. Every pixel of the infinite output image needs to be calculated exactly based on the relevant pixels of the input image. The small input image you have is only a small region of the actual infinite input image. The rest of the input image consists of dark pixels. For the purpose of the example, to save on space, only a portion of the infinite-sized input and output images will be shown. The starting input image, therefore, looks something like this, with more dark pixels, dot, extending forever in every direction. By applying the image enhancement algorithm to every pixel simultaneously, the following output can be obtained. Through further advances in imaging technology, the above output image can also be used as an input image. Truly incredible. Now, the small details are really starting to come through. After enhancing the original input image twice, 35 pixels are lit. Start with the original input image and apply the image enhancement algorithm twice, being careful to account for the infinite size of the images. How many pixels are lit in the resulting image? Okay, so this sounds like cellular automata again. And so it looks like the grid is 100 by 100. And since it can grow by 2 each step, we need 104 by 104 to store it. If we want to do 2 steps, well, I'm going to silently contemplate for a little bit. So we needed 104 by 104 to store the grid, and if we want an extra row of dots around the outside, then 106 by 106. We'll have y0 xi is a dot. No, maybe we'll do this at the end because then we'll know what the actual bounds are. So y isn't 0 at the start. We've got goes to -1 on the first step, -2 on the second step. We need a -3. So we want to read into grid Y, and we want to read 3 characters into it. And then, well, actually, let's just initialize everything to a dot. That's how it works. If we initialize everything to a dot, then it can't go wrong. Okay, so we now read in our grid. We don't actually know the width, but that's fine. We'll just assume it's 100 wide. Oh, no, that's not what I want to do at all. Ugh. So we'll step G to G2, we'll step from G2 to G. That's all for part 1. So what this needs to do is work out the 9-digit number and then look it up in the string. What are you going to call that? Get num. feel stupid. G, y plus dy, x plus dx is a hash, then n gains this bit. And that should walk over them in the right order. Starting at the bottom right. And then we want count lit. I think that might be it. Can't quite remember what I wrote here. Yeah, so that's wrong actually. We instead want GYX equals enhance over n, because enhance is a string. I need to write to G2, not to G. I expect part 2 is going to be probably the same thing, but you have to do a lot more steps. So that will probably just be increase the bounds of my arrays. Did I write an infinite loop? Or does it just take a very long time? I think I must have written an infinite loop. Oh, also, we'll be reading new line characters into the grid, but since we never compare against dot, we only compare against hash. That'll be okay. Well, I can't see an obvious infinite loop. Wow, that is quite slow. Well, hopefully it will do the right thing and we can just let it run. How long is that going to take? That's almost a quarter of the way through. Ah, that now looks like it might be an infinite loop. At the end of the first step call. Very curious. I wonder if we overwrote the bounds of a grid and... Well, I can't see the problem. Did I change anything? Very suspicious. Oh yeah, I changed the size of the array, didn't I? Okay, I think the problem is that I set height to be the y value that I read in. fact, let's not even do that, let's just hard code it. No, not the right answer. I wonder if it's quicker to recompile it with smaller bounds or just to run it. I think just to run it. That's correct on the sample. I did wonder if the first character here is a hash. It is. Okay, so what that's doing is, after an odd number of, because the first character of the first line is a hash, after an odd number of, lol, I wrote a comma there. After an odd number of cycles, it's filled to infinity with hashes rather than dots. That's funny. Some image enhancement that is. It inverts the colours. Is that going to do it? What that's doing is initializing all the spots we don't write to with a hash on the second grid, because we know that all the ones we don't write to. Oh no. Yeah, wow. Let's say we think all the ones we don't write to are surrounded by dots on the initial grid. I may need to be a bit more rigorous about my bounds. The only thing I changed was that, wasn't it? It'll be interesting to look at that binary then. Okay, the last character of the first line is a dot, which is good. That means all the hash 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 in empty space turns into dots. We need 514 for that, because bgets needs to give us 512 characters of enhancement, 1 character of new line, and 1 0. Well, let's read in the input more carefully. Well, we're now getting the sample input wrong. What? Oh, I see. Very smooth. Actually, I don't think that explains it all. Well, we've got the left-hand edge of the input. No, I don't understand that. How could that possibly be that? Oh. It's because X got reset to 4. Well, it is. Okay, fine. reading that correctly then. Okay, so we believe that to be correct. That's got all the hashes around the outside. But the example input doesn't want hashes around the outside. Well, let's see what it says on the real input now. Well, that looks believable. Well, I think that also looked believable. I wonder if we'll get 5,660 again. Have I already tried to submit that number? Yay. Now, is this going to be find the cycle length, or is it going to be how many hashes after 1,000,000 cycles? 50 times, okay. No problemo. So what we'll do is we'll stop dumping the grid and we'll do 25 lots of double step. And if we're doing 50 more steps, then we might need the grid to be 100 larger. Is that going to fit in memory? No. Cock. A 208 by 208 grid is 40k elements, so we can't have two of those. We probably can't even have one of those. It starts at 100 by 100. It can grow by 1 in every direction every step. So after 50 steps it may need to be 200 wide. How annoying. So what are we going to do? So we can store 16 bits per thing, which is what we're going to have to do. So, but we'll change all the 108s to 208. Instead of starting at 4, we'll start at 54. Instead of plus 3, we'll add 53. Okay, but instead of being 208 by 208, it'll be 208 by 13, which is 208 divided by 16. And for dot we'll put 0, for hash we'll put 1. No, what's happened there? Oh, I was meant to copy it to part 2. Ugh. Oh well, never mind. Right. So set okay, so lookup table for the division, and then we want to say grid of y x divided by 16 equals grid of y x divided by 16 or powers of 2n. Powers of 2 is defined in the standard library. got to be x mod 16. Okay, so that sets it, and when we look in the grid, okay, I think that'll be it. So I've worked out how we can test it on the sample input without having to recompile it. No, not that. We don't set that to 0 because we're using VZ malloc, but if enhance 0 is hash, then this one needs to be inverted. And that's all. And then it'll work on both the sample and the real input. Why is it stepping so many times? Isn't it supposed to only do 60? Oh, it is y plus 53. Fine. Let's work out how long we expect this to take. I'll time 10 dots. 2, 3, 4, 5, 6, 7, 8, 9, 10. That'll take 9 seconds. 10 dots in 9 seconds. 85 minutes. So, given that it's going to take so long, I think we won't bother running it on the sample. We'll just run it on the real input. I wonder if there's anything I could do to make it faster. So get num. Okay, we'll unroll this loop and get num. So that might help a little bit. And we don't need to store to n, we could just get num gxy there. And instead of comparing it to a hash, overwrite it with zeros and ones. So we compare it to hash up there before we overwrite it with zeros and ones, and then the only place we look at it is here. Oh, and that would be wrong anyway. So that should be if get gxy. Maybe we'll unroll this one and we'll get. What's our width going to be? We start at 54, we read in 100 and we add 53. So that's going to be 207, which is divisible by 3, isn't it? So that'll be fine. Let's try that then. Did I write that wrong actually? No, that looks fine. Oh, hang on, it starts at 1, so that'll land on 1 more than something that's divisible by 2. We're looping as long as it's less than width minus 1. So we thought width would end up as 207, so if it's less than 207, then we'll carry on, which means less than a multiple of 3. So the next one will be 204, which is less than 207. No, we'll land on 205, which is less than 207. So we'll write to 205, 206 and 207. And I think that's fine because they're all within range. But when getNum is called, that will be looking 1 out of range. So this is going to go past the bounds. So let's just allocate 14 there. So that took 2 minutes 53 seconds. Do one step. So to do 50 of those is going to be 144 minutes. So, see you in a bit. Right, well I'm back. We've got an answer. So let's see. Ow! Oh well, I'll have another look at that later then. I've got the correct answer now. I confess that I got fed up with waiting for the real hardware to run, with it taking 3 hours every time, so I reverted to the emulator. The bug was very stupid. It was that my 208 needs to be 209. That's probably all it needs, but we can change it everywhere. So basically, I think due to my loop unrolling, it was trying to read points one past the end of what was allocated in the array. So sometimes they counted as 1 and sometimes they counted as 0. Anyway, that's the end. Thanks for watching. Goodbye.